So to solve this question, we have 8a and b. I have spent time explaining this 8a. When I do that, I'm going to leave the b part of it to you. And number 9, I still have other questions like number 7. This is number 7. This is the geometry of the forces. The same approach you are going to use. So watch the way I'm going to solve number 8a carefully, so that you'll be able to solve the rest. Now, this is the question, the diagram. I have worked on this very well, if you can see from my explanation previously. This is 65. We have 4 forces: force 1, force 2, force 3, force 4. Now, in no particular order, I decided to name the force. I have to identify the forces. Started from here, 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 and here. So these are the 4 forces. I want to bring the forces in terms of magnitude and direction. They call this polar form. So force 1 is 7.5 in the direction 65. Force 2 is 5.5 in the direction 130. How we got 130? Look at it. This is force 2. Look at the direction. This is 50. It's inclined on the negative x-axis. So that means the inclination from the positive x-axis is from here to this point. And when you take away 50 from 180, you have this size. From here to here, it's 130. Force 3 is on the 3rd quadrant and inclined with 32 degrees with the negative y-axis. So to get the inclination from the positive x-axis, means we are going to use 270, because from here down here, this is quadrant 1, quadrant 2, quadrant 3. That's 270 degrees. Take away 32, you have 238 degrees. So that is the direction. Then force 4 is 310. 40 plus 270 will give you 310. So I've gotten their polar form, the magnitude and direction of all the forces, so that I can conveniently use the formula. So the next thing is to find the sum of horizontal force. This is the formula for each of the forces. This is the horizontal component for force 1, force 2, force 3, force 4. These are the horizontal components. So sum them up. That will give you the sum of all the horizontal forces. When you use your calculator, every value that is supposed to give you negative will give you negative. And when you solve, you see that cos 130 is going to give you negative, and cos 238 is going to give you negative, because 238 is in the 3rd quadrant and cos is negative there. 130 is in the 2nd quadrant, cos is negative there. So their values, they are going to be negative. 310 cos is positive, so the value is going to be positive. So when you compute carefully, you have your horizontal force, the sum, to be 1.9411. For the vertical forces, the same thing. The formula, remember the formula I showed you earlier, how we derive it. Look at it. Remember, this is the horizontal force is cos theta, this is vertical force is sin theta. So this is where we referenced our formula from. So when you do the computation, you have just sine making the difference. Change it to sine. Every other values are constant here. So when you compute it, the ones that will give you negative will give you sine is negative in the 3rd quadrant. That's why you have it here. Sine is also negative in the 4th quadrant. That's why you have it negative here. So when you compute, you have this value. So see, this is the sum of all the vertical forces. So magnitude from the formula earlier stated is this. Put your values, sum of x and y components. So you have this as the magnitude. So the magnitude of the resultant force is 2.14 in approximation to 2 decimal places. So the direction is the tan alpha is equal to this. Put their values. I have minus 0.4698. Now this value indicates that tan is negative, so tan is going to be in either. So how do you decide? You have to look carefully. The vertical force is negative, that is negative y-axis, so that's going to be this way or this way. Now but the horizontal force is positive, that is this way, so it's going to be the fourth quadrant. Positive x-axis, negative y-axis is going to be this quadrant. So the formula there is 360 minus 25 degrees, because the arctan of 0.4698 is 25.1641. So to get your direction, it's going to be 360 minus 25. That will give you 335 degrees. So the magnitude of the resultant forces is 2.14 and the direction is 335 degrees.